and then yeah. Okay, we are live. Do we want to check?
So, yep, we're live.
Okay, just wait like 10 seconds and then we'll start. All right, hello everyone. Welcome to another episode. Oh, I guess this is brand new. Welcome to an episode of Weekly Science News from Quirkcast. And this is your host, Tim.
And I'm Mikey.
And this is Sahil. Welcome, everybody. We're back after a very, very long hiatus. We had been trying a few things here and there, seeing if a colloquia style would also work as well, which we plan to do once every month or 2 months. So we'll keep you posted on that. And then this time we're coming back with vengeance of tackling popular science articles that spew basically stuff from like various concepts from theoretical physics, and then try to extrapolate them in various other domains. And some of them may be legitimate, some of them may not be legitimate. Let's find out. So without further ado, I want to mention some logistical things, and then we'll get to it. So if you haven't already, join our Discord channel, and also subscribe to YouTube and leave us any comments if you have any questions. And if you're watching this on YouTube right now, do leave us any comments or questions, and we'll get to them. So I guess, Tim, my first question for you is, I came across this article that talks about modified gravity. It's an article from Science Alert. And in particular with dark matter, from my understanding, like, that it's there because in order to explain the rotational aspects of galaxies, so stars don't fly away, you need this extra mass for dark matter. But what if there's just like the laws of gravity are not complete, and it's just modified gravity in the sense where it's not standard Newtonian classical mechanics like the 1/r squared, but something more to it?
Yeah, well, let us share. Let's take a look at what that article is about, right? And oops, hold on a
Yeah, I
second.
think there'll be lots of time to get into this debate of. Let's look at first. Let's look at the title of the article. In a wild twist, physicists have revived an alternative theory of gravity. So this is what Sahil was referring to. The title kind of gives you this impression that there's these two equally prominent theories that are like vying for correctness. And recently, something wild happened. This underdog came up and is now like, I don't know. It's that's kind of like what I get from the title, right? And this debate that they're referring to is usually just, it's like dark matter versus MOND. There are these two theories. Dark matter is the idea that there's invisible stuff we can't see, and MOND is this idea that maybe the laws of gravity aren't what we think they are. So these are the two competing theories in this title here that they're referring to.
Yeah. I think looking at the title immediately, I have some beef with it. I think first of all, Science Alert. I mean, don't get me wrong. I mean, it's their website, but like, is this really a Science Alert? Like, if I was still in the field as a researcher, I don't think this is a Science Alert, honestly.
How wild is this twist?
Yeah, and then
is this really a wild twist?
yeah, and some of these titles obviously are a little sensationalist. Like, is it that wild of a twist? And somehow, hey, we have somehow revived an alternative theory of gravity, as if there was a theory that died and somehow is alternative, and then it got revived. So it's like, is any of these statements true? Like, I mean, you got to give it to the editor and whoever's writing the article, right? They were able to jam so many loaded like descriptions for like a single thing.
It's very clickbaity. It's very clickbaity.
Right.
They're kind of appealing to your sense of like, people like the idea of like, the theory that was the underdog comes up and actually they're proven to be right in the end. And it's kind of like trying to give you the sense that something like that has occurred, which is so far from the truth.
Yeah, but
Yeah.
I think, well, I think if you look at factually exactly what this article is about, you can go a little deeper. It's literally just about one new study. Okay, so
Wait. Let's back up a little bit, right? So as Sahil mentioned, this is kind of they're talking about there's kind of like two camps in physics. The group of people who think that um, the motion of galaxies is explained by a theory called dark matter, and there's a camp of people who think that the motions of galaxies are explained by this other theory called MOND. But one camp is tiny. Like there's so much overwhelming evidence for dark matter over MOND. It's not even something that people debate like at all in scientific disciplines. And if you work on MOND, it's kind of like you have tenure and you're just like messing around. But it's not something that like is taken seriously. And this article is trying to make it sound like, yeah, there's this kind of like new example of this galaxy that doesn't seem to fit with the paradigm that people usually think of with dark matter. But what they don't mention is the overwhelming abundance of evidence for the fact that dark matter does explain the motions of like 99.9999999% of like observed galaxies.
yeah, so indeed, I dug a little deeper to see exactly what this article is about, and apparently, it has to do with one new particular paper that study one particular galaxies, and I believe for now we've already have like data on like is it millions or I actually don't know the number, like many galaxies now, and this is just one of them basically. And then what they want to study is the rotation of this galaxy, how this galaxy is rotating, and how well it matches up with the Mikey was mentioning, like kind of two camps, highly unequal camps of theories. One of them is MOND, a very controversial theory that's really not mainstream. And then there's the standard dark matter theory, which is well accepted, a scientific consensus, right? And previously, there was a study that says neither of those theories really adequately describe the rotation of this galaxy, right? And basically, that paper was just mentioning that, hey, something seems to be up, right? Out of this one galaxy out of many that we've studied doesn't seem to fit any particular profile. But this particular new study that came out is that it's basically throwing a small amount of shade on that previous study and say that maybe that previous study didn't consider all the possibilities, and this galaxy rotation curve, after all, maybe, and maybe is a strong word, maybe not incompatible with the theory of MOND. So there's a many negatives here.
So Mikey and Tim, I just want to clarify one thing. You guys mentioned that like mod isn't as predictive as dark matter. Like what is like what's so bad about mod? Like why is it not a robust enough idea to think that maybe gravity changes based on the scale of how you look at things? Like maybe it's 1/r² when we're close to Earth, but when we're really far away, it could maybe be something else. So what's wrong with that idea?
The key difference between like MOND, the MOND idea and the dark matter idea is if you kind of look at how the theories have evolved. So MOND starts out with like a simple idea. Maybe there's some correction to Newton's laws, but then we make a new observation, and then MOND has to like adapt to fit that observation. And that's happened again and again and again and again, where now MOND is this like ridiculously complicated thing. And it's like, yeah, it could be that, but like you're working really hard to make it work. Whereas with dark matter, it's just one simple idea, and everything that has been discovered, all new measurements have more or less been consistent with that original idea. So the MOND camp just seems like they're stretching it. Yeah.
Yeah, and I would also add that in terms of science, what we call modified gravity is really lacking. So the pinnacle idea with modified gravity, as the name suggests, it's modified gravity. It just means that, hey, if your equation does not work, let's just add a few terms to it. Just like add in a few terms by hand to see that it fits data. Like, unfortunately, that's not science. Science does not permit you to just add random terms to an equation. Science is very much a top-down science where you propose some new fundamental laws, and then from those fundamental laws, you see that the equations change as a result, right? So basically, you cannot really put the theory of modified gravity and the theory, let's say, of dark matter on the same footing. Because the theory of dark matter is that we suppose there's an extra kind of matter that we do not see. And then you look at the consequences on how it shows up in various equations and observations, right? And it's not just how galaxies rotate, it's also how the formation of the Big Bang is the growth of structure of the universe, formations of galaxies, in addition to galaxy rotations, right? Versus modified gravity is literally just, you look at these plots of how galaxies rotate. You say, oh, it doesn't work. Add a few terms and just make the curve fit, right? It's not. I would say it's not like a bad start. Let's say if you have a problem that's really hard, you don't know what to do. Sure, you can try to modify your equation and kind of do a bottom-up approach. But then if we have something like the theory of dark matter that's way more comprehensive, it stops making sense, right? It's like, hey, come on, guys, let's play the science game for real as opposed to playing this like data fitting game, basically.
Yeah, that makes sense. So if I were to summarize, basically what I'm getting from this is that mod is like a theory or a function that's held together by bubblegum and baling wire, versus dark matter is a little bit more robust of a theory.
Yeah. Let's rate this article because
Yes.
So okay, I feel like this article is, the more I read it, the more I dislike it. Like it kind of hits like all the worst parts. It like makes it seem like something exciting is going on when there's not. And so this is like almost like the worst offender in terms of like clickbait stuff that you probably shouldn't click on. It's basically takes one result that is going a little bit against the grain and makes it sound like the tide has shifted in some epic battle. I give it definite pass on this.
Yeah, I would say for me it's the same. And even if you're really interested in that thing, if you click through the articles, you find the papers, it's extremely just technical and it's just not that interesting. So at the end of the day, don't waste your time. I think even the experts will agree with that. So a hard pass for me, yeah.
All right, then I shall read no more. So Tim, can you share the next article?
Yes, give me one moment.
I'd like to discuss with you guys.
Yes, let's see if I can do this. All right, I think this is not an article that.
I don't think you are sharing your screen, Tim.
Oh,
there you go. Yeah,
yes.
You're good. Yeah. So this article talks about, could quantum mechanics be responsible for the Mandela effect? And for people who don't know what the Mandela effect is, it's basically where two people remember the same event, like to a certain degree of closeness, like differently, completely. So it's just having like different memories of the same event. And so could quantum mechanics be responsible for that? Mikey, you go first. I called them Tim first.
Yeah, let me do my shit.
Well, I think this, like, I clicked this article because I think they're just kind of poaching people who don't know what the Mandela effect is. Like, this is not something that people like actually argue about, right? Like on a serious academic level. I don't think so. So I clicked on it because I didn't know what the Mandela effect was. And then I see all these examples of the Mandela effect, which are like very obvious, like a quote from Star Wars, like, oh, was it really that? Like, maybe we should get some context, right? Like, so what's this article?
Yeah, first of all,
It's,
what the heck? Yeah, what the heck is the Mandela effect? I guess it says it, right? False memory of some historical events.
Okay, I think it's kind of like so. there's kind of this offshoot of this idea of the theory of quantum mechanics, which everyone knows is true. There's kind of this offshoot idea that maybe our universe is actually part of this vast multiverse where every single possibility exists. Like, you made a decision to go to the grocery yesterday or the laundromat. Like, there's a universe where you made the other decision and it branches out infinitely. And the Marvel Cinematic Universe takes advantage of this idea a lot, especially recently with the Doctor Strange movie. But it's like the idea is like, can physics provide evidence for the idea that there are multiple universes with alternate versions of yourself running around? So that's basically what the article is asking. Is that possible?
Yeah, I'm not even sure where to begin with the idea of, like, even just the title. I would never imagine one could put quantum mechanics and the Mandela effect on the same sentence. It's just like completely different, right? I don't know.
It's actually very similar to the Doctor Strange plotline for the recent movie that came out. Like in there, in that movie, the many worlds interpretation of quantum mechanics is correct, and when we dream, we're actually accessing these alternate histories, alternate versions of ourselves. It's actually kind of funny. It's possible that the timing of this article is taking advantage of the plotline of Doctor Strange. Also.
So, could it be responsible? I mean, is it even possible for it to be responsible?
Well, let me first say that the answer is definitively no. I mean, like,
okay, it's not. It's not. You can't show that it's not true. But it requires a huge amount of narcissism to interpret, the many worlds interpretation of quantum mechanics as somehow placing like the evolution of our lives in some.
Okay, it depends on what you mean. Like, if you argue that quantum mechanics is a law of fundamental physics, then quantum mechanics is responsible for everything, not just the Mandela effect. Like, everything, just the fact that we are on Earth, the fact that you're walking around, is responsible for everything. So I say that we should give it a little, like, in order for this sentence to have a little more meaning than this trivial statement that everything is quantum mechanical, it has to be more direct, right? It's like somehow misremembering things has anything to do with quantum mechanics. Of course, ultimately it does, right? The molecules in our brain ultimately obey quantum mechanics, but quantum mechanical effects has very little to do with dynamics of the brain, and that's been tested thoroughly. By looking at electrical signals, for example, from the brain, that it's macroscopic, that quantum mechanical effects are highly, highly, highly suppressed because of the laws of large number. So I think it's tough to argue, to have, to make this sentence more meaningful than just the fact that everything is quantum mechanical.
I think it's safe to say that no one who thinks about physics seriously, with like maybe one or two exceptions, thinks that there's some connection between quantum mechanics and consciousness. It kind of started out from this idea that basically, hey, quantum mechanics is weird, consciousness is weird, maybe the two are linked, but it's not an idea that you can really get any kind of like useful insight out of. You can always say, oh yeah, it could be true, and no one can prove you wrong, and it sounds very kind of provocative. So I think that's why this idea is persisted.
Yeah, I would say this article is rather empty, right? Like, quantum mechanics, sure, it's uncertain. We get it. That's true. The idea of parallel universe is more like a thought experiment. Sure, that's fair. And there's some ideas about multiverse, which is parallel universe, not multiverse. These are distinct concepts. But at the end of the day, I think the article says that, well, at least it came up with the right conclusion, I think. Basically it's just that the answer seems to be no and no. But I think it seems obvious. It's like when you look at the article, it'd be like, yeah, no. So I don't think we have to
So
go.
if I'm gonna rate this, I feel like it's kind of the opposite of the last one, where I feel like if I look at the title, knowing what the Mandela effect is, it's like almost offensive initially, but now it just seems like it's an excuse to kind of teach people a little bit about various ideas in quantum mechanics. I guess it's pretty honest about that. So I would say if you're not really familiar with these ideas, maybe it's it wouldn't hurt you to click on this article, because you learn a bunch of true things about quantum mechanics and physics, and then at the very end you'll realize you were duped into clicking it. But that's okay.
You, Tim?
Well, I would say okay. At least this one sentence is okay. If you click on the title and then you see this one sentence, then
That's at the very end. So.
you come out ahead. But okay, well, it's not blatantly wrong. So let's put it that way. It's still a pass for me. But if you're really curious about these ideas, I guess it wouldn't harm you so much as to really click on it. But
That's fair. That's fair. All right, shall we move to our third and final article?
yes, let's do that.
So the third and final article is how the multiverse could break the scientific method. Now, I guess before we dig deep into this article, could you guys maybe sum up what the scientific method is? I think people have some idea, but how to rigorously formally think about it in layperson language.
Yeah, sure. I think actually I feel like this article, it kind of brings to light something that's not well appreciated, but it almost doesn't explain it far enough. I would almost say that the multiverse idea has broken the scientific method. And what does that mean? I think when a lot of people think about the scientific method, it goes back to this philosopher named Karl Popper, who said that for a theory to be a good scientific theory, it has to be possible to falsify. It has to be possible to prove the theory wrong. You can have an idea, like kind of we're talking about with Mon. You have an idea, and then you have new evidence. Okay, your idea changes. And then there's new evidence. Okay, your idea changes. A good theory has to be something that can be put to the test and actually put its life on the line, be able to be proven wrong, and then pass that test. So this article is basically, I think, they don't say it directly, but they're basically kind of hinting at this aspect of the scientific method. The multiverse kind of throws a big wrench in.
So can you explain more mechanistically what the scientific method is? If you're designing some experiment, at a super high level, what is the scientific method in relation to that?
Basically just saying that if you have a theory, you have to be able to propose an experiment where I can go to the lab and do a test, and if the outcome is A, your theory is wrong. If it's B, it's right. And your theory has to take that test and pass that test.
Yeah, so yeah, I guess even going back to the Mon idea, even though it's not one of our favorite theories, even for ideas like that, you can still, for example, look at galaxies and how they rotate. And you can say, hey, if it doesn't obey that law, then Mon is wrong, or the Kodak matter model, or some specific version of it is wrong. You could say that. But the issue of this article is saying that ideas such as the multiverse is really teetering on this border, right? There doesn't really exist a conclusive experiment that you can do that with, right? I think this is one of the key points of this article.
So is it just saying you can't use the scientific method to falsify multiverse or to prove that it's true?
You really can't use the scientific method in cosmology generally, because we only have one universe, right? You can't make another universe and test your idea. So it kind of evolves in a different way from laboratory science. You know, particle physics, you know, you have a theory and you literally do the experiment, outcome A or B. But with like cosmology, it's a lot more like archaeology, right? Because you're uncovering kind of relics from the past, trying to piece together a consistent history with other things that you know to be true. So it's like a very different kind of game. And I
Yeah,
think people didn't really like appreciate this until the multiverse idea kind of like, okay, now it's just what do you do?
yeah, and I guess you can have what we call thought experiments, even though they're not practical. Also not falsifiable, by the way. Like thought experiments are not real experiments. But if you imagine you can create multiple universes, then multiverse ideas could tell you how those different universes could behave. And if you, I mean, I don't like to use this word, but if you're like God, you can kind of put your fingers in every universe and probe it to some extent. You could, in principle, test your hypothesis and prove these ideas of multiverse wrong. But we just cannot do that because generally, when you have multiverses, like one universe and the other universe is completely disconnected. Like we live in our own universe. There's no way we're ever going to visit these other universes. So there's never going to be a direct probe of evidence of these multiverses. That's not to say that there could be side effects of these multiverses, but those are tend to be highly um, those tend to be highly subtle and sometimes not really prominent. They're not the most prominent features of the theory.
I see. So
Unless, unless we find out that quantum mechanics is responsible for the Mandela effect, and then you can go to other multiverses just by remembering things incorrectly.
uh, so are you saying we can't? Scientific method is not applicable because there's one universe, and the scientific method relies on aggregating results that are similar enough to each other, so you can do statistics on it, but you can't really do statistics on like a single universe.
Yeah, you can't really prove an archaeological theory wrong either, right? I guess. I mean, you can find lots of evidence to the contrary, but you can always find some way to posit that it could have been the way you say.
Yeah, and also it's because theoretically the experiments are too big because one experiment is an entire universe. We just couldn't afford to do it. Like sorry.
So on that note, should we read this article in this universe or another universe?
I think that this is worth reading if you're into reading popular science stuff because yeah, it kind of shines a light, in my opinion, on a fact that's kind of underappreciated, and it has a lot of good history in there. You know.
Yeah, I would say yeah. I think one should go ahead and take a read. Indeed, the multiverse could break the scientific method, and that's something we should seriously think about, like what it means to do science. So it's I think it suits the title. It is big think. So it's a read for me.
All right, all right. So then on that note, I'd like to thank everybody for joining us, and we'll see you all next week.
All right, see you all next week.
Yeah. Bye.
Hey, I think that went really good overall. Well, I got to go